This is an analysis of the rational function in example 8c from notes 4.1, days 2 and 3. We're going to begin our analysis by factoring the numerator and the denominator of the rational function. The numerator is the difference of squares. X squared minus 1 factors as x plus 1 times x minus 1. And the denominator factors as x plus 3 times x minus 2. Okay, we're going to go through the steps of analysis. First, let's find the y-intercept. Find the y-intercept. We're going to let x equals 0. So we're going to evaluate f of 0, which in this case is negative 1 over negative 6, which is 1, 6. So y-intercept is the order here, 0, 1, 6. Next, let's go ahead and find the x-intercept. To find the x-intercept, we are looking for values that make the numerator 0, but do not make the denominator 0. We're looking for values that are part of the domain. In this case, we're going to examine the numerator. We have two x-intercepts, one at negative 1, 0, that comes with a factor x plus 1, and another one at 1, 0, which comes from the factor x minus 1. Both of these have odd multiplicity because the factor only occurs one time in the numerator. Next, let's go ahead and find vertical asymptotes. Vertical asymptotes occur where the denominator is equal to 0, but the numerator is not equal to 0, or the factor, if they're both equal to 0, then the factor cannot be canceled out in the denominator. In this case, we're going to have two vertical asymptotes. One from the factor x plus 3, which is going to be x equals negative 3, which is going to have odd multiplicity, and another one at x equals 2, also with odd multiplicity, because those factors only occur once in the denominator. This function does not have any holes because there are no common factors, okay, in the numerator and the denominator, so we don't need to worry about that in this case. Then we're going to look at the end behavior or the infinite asymptote. So I'll put that up here. We're going to examine infinite asymptotes. So we're going to see if we have a horizontal or slant asymptote or something else. To begin, we'll compare the degree of the numerator, which in this case is 2, and the degree of the denominator, which is also 2. When the degree of the numerator equals the degree of the denominator, we have a horizontal asymptote, and its equation is going to be the ratio of the leading coefficients, which here is 1 over 1. So we're going to have a horizontal asymptote being the line y equals 1. Next, we want to know, does our graph cross the horizontal asymptote at y equals 1? To determine this, we're going to set the original equation equal to the equation for the horizontal asymptote. And then we're going to solve and see if there are any x values for which this is true. So I'm going to multiply both sides of the equation by x squared plus x minus 6. I can subtract off the x squared terms, leaving us with, and I add 6 to both sides, 5 is equal to x. Let's make sure that 5 is part of the domain. It is. It doesn't make the denominator 0. So this graph intersects the horizontal asymptote at the point 5 for x, and then the y value we can find out right here because the horizontal asymptote is y equals 1. So the y value has to be 1. So it intersects at the point 5, 1.